everyone. Thank you so much for coming to this lesson. So today we're going to be going through coordinate geometry and straight lines. So the learning objectives for today is going to be to understand and be able to use the equation of a straight line, to be able to use the gradient conditions for two straight lines, and to be able to use straight lines to find midpoints, distances between 2 points, and intersection points. So like always, there's going to be timestamps in the description of the video, so feel free to skip to any parts you want to. So I've written down the three forms of equations for a straight line that you need to know. So the first one we have is y minus y1 is equal to m times x minus x1. Second one is y equals mx plus c. And the third one is ax plus by plus c is equal to 0. So the question in your exam, it may specify which one to do or may not. So it's just useful to know all three ways. So if we try with an example, that will probably be the most useful. So the first form we have here is probably the most easiest one to do because we have most of the information. We just want to know what m is. So in these points, we just want to label the points we have. So we have x1 and x2. That's just equal to -3 and -10. And then we have y1 and y, sorry. So if we try this question, we want to find the equation of the line that passes through the points -3 and 10 and 1 and 4. So the first thing we do is we just want to label the points we have. So we have x1, y1. That's just equal to -3 and 10. Then we also have x2 and y2. That's just equal to 1, 4. So now the next thing we can do is you just want to find m, which is equal to the gradient. So if you remember, m is equal to the change in y over the change in x. So it would be y1 minus y2 over xy minus x2. So we just plug in the values for that. So we get 10 minus 4 over -3 minus 1, which is just equal to 6 over -4, which is equal to -3 over 2. And the next thing we do is we just plug in the values that we have here into that equation. So we'd have y minus 10 is equal to -3 over 2, x minus x1, which is just -3, so it's just +3. Then if we times, and then see that is the equation in the form y minus y1 equals x minus 1. And then using this, we can try and put it into the form y equals mx plus c. So the first thing we can do is we can expand the brackets. So let's do this in another color. So let's just label this as the first form. And if we try for the second form, if we just expand the brackets, we would get y minus 10 is equal to -3 over 2x minus 9 over 2. And then we just rearrange. We already have mx, that's just -3 over 2. So we just want to find c, which is also the constant, the y-intercept. So we can just add 10 onto that side to find the constant c. So then we'd get y equals -3 over 2x, and then -4 over 5 plus 10, that's just plus 11 over 2. And that's just the answer in the form y equals mx plus c. And then the last thing you want is just in the form ax plus by plus c equals 0. So what you want to do for this one is you want to first, that these both have a common denominator of 2, so we could just times everything by 2. So then we would get 2y is equal to -3x plus 11. And then we could just bring everything onto one side because we want something is equal to 0. So if we add 3x to the left-hand side, we would get 3x, then plus 2y. And if we minus 11 from both sides, we get -11, and that would just be equal to 0. So that's just the 3 ways you can write out an equation in the 3 different forms. So moving on to be able to use the gradient conditions for 2 straight lines. So the 2 types of lines you need to know are parallel lines and perpendicular lines. So parallel lines, the definition of two parallel lines are ones that have the same gradient. So they would look something like this. So they have as they have the same gradient, they would never meet. So they would just keep going like that. And then, and you just have to remember to have the same gradient. So for example, if you had one line with the gradient 2, and you'd be asked to find a line that's parallel to that line, the gradient of the other line, line 2, would just be 2 as well. So the other form you have are perpendicular lines. So these are lines that look like something like this, and they're at right angles to each other. So lines that would look like that. And to find the gradient of those, if you had, let's say L1 has a gradient 2, to find the gradient of L2 that's perpendicular to L1, all you do is you do -1 divided the gradient of L1. So let's say L1 has that's equal to 2, L2 would just be -1 divided by 2, which would just be -1/2. So let's try and use these definitions in a question. So we have the equation of the line L1 can be written as y equals a third x plus 4. And we want to find the line perpendicular to L1 that passes through the point -2, 4. So using what we did previously and using these definitions, feel free to try this question out for yourself. You can pause the video. So now let's try the question. So if we want to find the line that's perpendicular to L1, we know that the gradient of L2 would just be -1 divided by, would be the m of L2 would be -1 divided by a third, which is just equal to a -3. So then if we were to write out the new equation in the form y equals mx plus c, we could use that form of equation. Then we could just put our m would be -3. So we just have y equals -3x plus c. Now the next thing we want to do is we just want to find out what the value of c would be. So you could do that by plugging in this point. So you'd have x is -2 and you'd have y is 4. So you can just plug in those values. So you'd get 4 is equal to -3 -2 plus c. So you'd have 4 is equal to 6 plus c. So then if we -6 on both sides, we'd get -2 is equal to c. So then the equation of the line perpendicular to L1 would just be equal to y equals -3x minus 2. They also haven't specified which form they actually want it in, so you could just leave it like this. But if they do specify, then just change it into the form using what we just did previously. Moving on to trying to find midpoints of line segments. So I've just written out the midpoint formula. It would just be, so let's say you had a line like this and you had one point here, and this is XA and YA, and you have another point here which is YA and YB, and you just want to find the midpoint here. That midpoint would just be equal to XA. You just add the two, sorry, this would be XB. So you just add the two coordinates, XA plus XB, and you just divide that by 2. And then you'd add the coordinates YA plus YB, and you just also divide that by 2. Then using this formula, we can try to find the midpoint of the line segment 4, 3, and -2, 5. So feel free to pause the video and try it out for yourself. So yeah, let's try using, so all you have to do is when you're solving the midpoint is you just plug it into this equation. So you would have, you just write it out, you'd have XA, XYA, and that's just equal to 4, 3. and then if you'd have xb, yb, that should equal to minus 2, 5. So then the midpoint, that should equal to 4, so xa is 4 minus 2 over 2, and then ya is 3 plus yb is plus 5 over 2, and that should equal to 6 over 2, and then 3 plus 5 is 8, 8 over 2, and that should equal to 3 over 4. So that's quite simple. That's how you find the midpoint of 2 points on a straight line.